Okay, let's have a look at this question. For today is 6th July, and this is a cubic function first. Um, for cubic function, sketch the graph first. Look like this because the number before the highest power is positive, so it's a go up. And which means when you ask me the x coordinate of the local minimum should be here. There was a two local, the stational or turning point. In other words, is somewhere they call it the stational points. There's a new term, stational, stationary point. Yeah, same thing. There's a turning point. Just at this exactly at this point they don't move. Their gradient equals 0. So okay, the local minimum obviously is the right one. So but the method how to figure out the x value is the same. So we do the differentiation first. Dy over dx equals 9x squared minus 18x minus 27, and let this equal 0. Solve this quadratic equation. So I will do it by hand. And if you have a graphing calculator and know how to do it, you can use calculator. So on the both sides, I notice number 9 is a common factor, so I divide by 9. So leave me x squared minus 2x minus 3 equals 0. On the both sides, I factorize into two brackets, and x minus 3, x plus 1 equals 0. And either x minus 3 equals 0 or x plus 1 equals 0, which leaves me x equals 3 or x equals negative 1. So obviously, I look at the graph, I know the big number, it means the right one. So x on the x-axis is 3, and this one, left one, is negative 1. So for local minimum, x value, the x equals 3. That's the answer for the question number 1. And for question number 2, we need to explain how you know this is a minimum point. Sorry. So minimum, I check on the both sides of the number 3. So both sides, but pay attention. You need to pick some number very close to 3. You cannot just pick a number very, very small, like smaller than negative 1. It's not okay. So you should pick a number like choose number x equals like 2. It's okay. So it's 2 in the between negative 2 and 3. So it's x equals 2. Now I'm looking at the gradient on this number for x equals 0. No, sorry, for x equals 2. So which means I substitute this number into not original function but the gradient function. So it's 9 times 2 squared minus 18 times 2 and times 27. Okay, give me let me think about it. 2 squared is 4, 4 times 9 is 36. This is 36 as well. Well, they are same. So they cancel each other. It's a negative 27. It's a negative. So I just write down the negative, which means between negative 1 and 3, the curve is going down, right? So I choose another number, x bigger than 3. I choose 4. So I substitute it back to the gradient function as well. So 9 times 4 squared minus 18 times 4 minus 27. This is 16 times 9. This is 4 times 8 times 9, 4. So it's 20. The difference is 8 times 9 is 72. 72 minus 27. It's 45. so it's a positive, which means on the right side to the number 3 it's a go up, which will tell us exactly this is a local point. So x equal 3 is actually, if I want to make a looks better, I don't use the I don't write down like x equals 3 it's a local minimum point. X equals 3 is just an x value. I don't that's not a point, so I just follow the question itself. So I write this. This means I didn't get the whole points coordinate because they didn't ask for that. So I just write this is a minimum points. Yeah, that's better. Okay, that's for today's question.